Hello and welcome to another Professor P video. Today we're going to talk about Starlink, and I get a lot of questions about Starlink. And so what I'm going to do is just give a brief overview of the different types of Starlink antennas, talk about their plans a little bit, and then talk about connecting Starlink into Peplink and then using Starlink with Peplink. So let's get started. There are three types of Starlink antennas. We have the standard antenna. This is best for residential users, everyday internet, or like pop and go RVers, where you can move this thing around. It's going to connect to one beam at a time. Then we have the high performance antenna. This is great for our enterprise customers, business customers, maritime customers, and it can do 3 beams at a time. In other words, it can connect to 3 satellites at the same time. And then we have the flat high performance. Once again, maritime applications and in motion RV or in motion mobility, where you're attaching this to a vehicle and you use this while driving. This is what I have installed on my SpeedFusion vehicle. You can kind of see it right there and the top of the vehicle right there. There are different plans, and the different plans matter. You have the residential plan and the business plan. These are going to be priority-based connectivity, as well as fixed location. So if you buy the residential plan, it's going to work at your address. If you buy the business plan, it's going to work at your address. They're not designed to be moved around or roamed, as might be stated there. And if you do move the antenna, you then have to go into the Starlink app and change the location. So these are cheaper plans designed for fixed installations. And if you move the Starlink, you're going to have to then log into your app and change the destination, the address that you're currently at. And I believe there are some limitations on how many times you can change that address in a period of time. But more importantly, the residential plan has a lower priority and no static or no public IP address. The business has a higher priority with a public IP address. And so you're going to get just a little bit more. And the business with, if you compare that with the high performance antenna, it's just going to give you some much better connectivity. Roaming allows you to move the antenna from location to location. So we take that residential and or business, we add roaming to it, and now you have the ability to move it around. And so that's going to let you go from campsite to campsite or from maybe different business location to business location. So if you're using a Starlink as a business backup connectivity, where you maybe have 1 or 2 Starlinks for a region, and then in the event of an outage, you go deploy, you want to make sure you have business with roaming. If you have a house internet and then you also have an RV and you want to be able to take the router with you and then set it up when you get to a campsite, you want residential with roaming. Mobility allows you to use the router while in motion. So I have the in motion or mobility plan on my Starlink high performance, flat high performance. This allows me to mount the router or the Starlink to the roof of the vehicle. And then while I am driving, I can use Starlink. And so no matter where I go, there's no setup time, there's no activation time. It's simply just going to work all the time. And then we have maritime and aviation and IoT. On the maritime and aviation, these are going to be much more expensive versions of your mobility, right? The idea here is you have like 2 or 10 or 12 Starlinks in motion that work for maritime applications to provide high bandwidth, whether it's for a super yacht or a cruise ship, etc. These are pretty expensive plans, usually based on capacity or throughput. You can connect the Starlink as Wi-Fi WAN. So one of the easiest ways to connect the Starlink is to use their modem. You plug it into the Starlink. It's going to create a Wi-Fi network. And then from your Peplink router, you can just connect Wi-Fi as WAN and connect into it. One of my preferred methods is connecting as an Ethernet WAN. Ethernet WAN allows you to take either the USB dongle that you can buy for like $29 on the store and plugging it into a modem that comes with the Starlink and then plugging into the Peplink WAN port. Or if you buy the flat high performance or the high performance, it comes with their power brick Ethernet, and then you can bypass their modem altogether or their router altogether and go right into a Peplink router via Ethernet. Ethernet WAN is my preferred method. It is what I use on all of my RV installations or Peplink installations. I do like the Ethernet connectivity. When you're doing Ethernet connectivity, there's a couple important things. One, make sure that your MTU is set to 1500. Make sure that you're in DHCP, even if you have a public IP. Make sure you program your upload and download based on your plan or capabilities. Starlink is modifying the plans and the throughput, and you want to make sure that you program the upload and download so that it can load balance those connections properly. If you only have Starlink and nothing else, the upload and download is not as important because you only have one internet connection. But if you're load balancing this or bonding this with Starlink and 5G, or Starlink and an Ethernet connection like a cable modem or something like that, you want to make sure that you are programming the throughput effectively or based on where you are. It's also important to remember that there is a difference between real-time throughput and accelerated throughput, which we'll talk about here shortly. But for right now, you just want to make sure that you have your Ethernet settings set properly with the MTU of 1500, an upload and a download, and DHCP enabled. Your health check. Starlink is a cloud-based service, and they don't like ICMP attacks clogging up their network. And so we've come up with a good health check that seems to be really reliable. You want to set the health check to ping, and then you want to ping public DNS like 8.8.8 and 9.9.9 or some variant thereof. And then you want to make sure that your health check settings are 5.10.5.5. So 5.10.5.5. That's going to be the optimal health check settings on your WAN, whether it's Wi-Fi WAN or Ethernet WAN, to make sure that you're not getting any false positives for down or vice versa. And so as you're roaming around or setting up, taking into account latency and dishes moving around, this is going to give you the least negative effect related to any sort of outages. If you want to use SpeedFusion and you want to run VPN tunnels over that. So if you're using Starlink for work or to connect an additional firewall or additional IPsec network, Starlink doesn't support IPsec. And so you can tunnel IPsec over SpeedFusion. In order to tunnel IPsec over SpeedFusion, you need to make sure you turn off IPsec NAT under service pass-through in your router. So if I go to my router and go to advanced, go to service pass-through, I'm going to turn off IPsec NAT. This is going to allow VPNs to truncate over SpeedFusion. And so basically we can wrap your IPsec or your work VPN inside of our SpeedFusion bonding. But in order to do that, you want to make sure you turn off IPsec NAT. Starlink accelerated versus real-time throughput. Starlink is a low Earth orbit internet. And so there are inherent latencies and or capacity limitations. And so like any satellite operation, they use TCP acceleration in order to increase perceived throughput. What this means is that there is a difference between your real-time throughput and your browsing throughput. So if you go to fast.com or speedtest.net and you download or upload or you're browsing the internet, those things can be cached or accelerated using TCP acceleration. Real-time protocols use UDP and are not able to be accelerated because they're real-time. And so you might go, hey, when I do a speed test on my Starlink, I'm getting 200 by 50, but when I do a bonding test or a VPN test, I'm getting 10 by 20 or something like that, or 20 by 10 or 50 by 10 or whatever, 90 by 10. And that's because that's the real-time throughput. That's your non-accelerated throughput that you're getting. That is not a limitation of Peplink or any other router. It's simply the real-time throughput allowed through the Starlink router or Starlink network. And so depending on your use case or your need, you might want to split your traffic so that Netflix and YouTube and Hulu and things like that just go out Starlink and let it be accelerated, where your voice, Teams, video, and business applications that might be real-time capacity get bonded. How are we using Starlink? Some people use it as a primary and their only internet. Some people use it as a backup. Some people bond Starlink and 5G. Some people bond multiple Starlinks and 5G and multiple 5Gs. And so the idea is you can either use it as a primary, a backup, or an aggregate. In other words, combining capacity. Most of the time that we are doing deployments, we're doing some level of aggregation. So whether we're bonding more than one Starlink together, or we're bonding Starlink with 5G, or we're doing Starlink as a primary with 5G as a backup, or Starlink or 5G as a primary with Starlink as a backup, there's some level of that when you're talking about mobility. So on my SpeedFusion vehicles that I travel the country in, I have a Starlink flat high performance, a single one with an HD4 MBX 5G. And that gives me 4 5G connections possible, and I'll showcase that in a few seconds here. But how we enable Starlink with our policies is going to be important, and I'll show that as well. In order to shape our traffic, we want to use outbound policies. This tells us how our network is going to use Starlink or 5G and or SpeedFusion. And so we want to make sure that we are defining how the technology is being used. If you're using, for example, SpeedFusion Connect, our cloud-based service, that service can block Netflix. So you might want to use it for Microsoft Teams and Google Chats and Zoom, but not for everything else. And so you can use destination-based connectivity with SpeedFusion Connect, or you can use outbound policies to shape traffic by client type, like my TVs. If the client is my audio video devices, any go over Starlink high performance. And so I'll show you how to do that. Traffic shaping is the key. It's how we tell the traffic to work, and I'm going to demo that in real time for you. So when we're talking about connectivity, you might have a SpeedFusion Connect profile, and in which case you can route by cloud application. I have an entire YouTube video on outbound policies and routing. So if you haven't seen that, I would advise you to go take a look at that. So if we're going to use SpeedFusion Connect, you can use route by cloud application, which means you can send Google, Zoom, and other services out SpeedFusion Connect. Or you can create a specific SSID like RV-SFC Protect and then just route anybody connected to that Wi-Fi over SpeedFusion. Or you can route by LAN client. It's a really easy way to send clients specific traffic out SpeedFusion Connect. I personally have my own office connection, and so I connect to my office network and use that to connect. And so when I do that, I'm basically send all traffic out the SpeedFusion Connect. So if I go to my status and my SpeedFusion, you can see there's my Starlink, AT&T, T-Mobile, and Verizon, and they're all being used at the same time. And you can see their latencies are all relatively close. I mean, they kind of moving up and down, but they're right there in the 80 to 125, 150 milliseconds. And so I simply just bond all the traffic, and then that way, if my Starlink is able to carry that load, it helps me as I'm going. And most of my work are Teams meetings and things like that, and so it doesn't affect me at all. That being said, we can go to advanced and outbound policies, and we can actually create policies to route traffic as well. So if we're not using SpeedFusion Connect and we want to just route out regular SpeedFusion or customize how traffic goes, we can create an add rule, and I could say source associated SSID, renegade bonding, any enforced out bonding, and I could say bonding. And basically, if you connect to the SSID renegade bonding, it's going to bond the traffic. I could also say TVs. I can say if the source is a client type, and I can say audio and video, destination any, I can say enforced out Starlink high performance, or I could say priority Starlink high performance, and then maybe go out just my cellular connections. I like this too. If you do priority Starlink flat high performance, fail through the next rule, enabled. So basically say if the Starlink is working and it's an audio video appliance, send it out that Starlink high performance. This is going to say, this is going to be obviously my cheapest connection because it's a Starlink. If not, then just go out, do your standard thing, right? But if the Starlink is working, I want my audio video appliances to connect to Starlink first. And so once again, I have an entire YouTube video on outbound policies and traffic shaping and SpeedFusion Connect. But the key to a good utilization of Starlink is to have that set up. The other thing I'm going to highlight here is priority. On the dashboard, I have a priority. If I drag these cellular connections down to priority 2, they're all going to go in a standby state, and my Starlink is going to be by itself. This means that the Starlink is the only available internet connection. I don't particularly like that when I'm trying to traffic shape, because here, if they're all enabled, I'm not waiting for them to turn on and off. So it makes my connections more smooth. If Starlink fails, my AT&T and T-Mobile and Verizon are already connected, and therefore they're not going to be negatively affected as if, transitioning those services. So think about this WAN connection status really as WAN interface status, right? You're basically saying, is this interface on or off? So, and if it is on, then the router can use them. Then inside SpeedFusion, I can set up interface statuses. So I can create a new tunnel called Starlink FHP. Then I can change all my connections to WAN to priority 2 and turn on the FHP. This is another tunnel being bonded that the Starlink FHP is the only internet being used. If Starlink is available, it'll use only that. Otherwise, it's not going to use those. So I can have one that's bonding all my traffic and another one that's just Starlink FHP. I hit save and apply. Now I can go to my outbound policy and, for example, my TVs, and I can send it right over Starlink FHP. So in the event that if my Starlink is working, this VPN is going to use Starlink. Then if my Starlink fails, then it's going to use cellular without interrupting services. That's what we call hot failover. My Starlink and my cellulars are turned on, but the Starlink is being used primary. And then only if the Starlink fails do the cellulars kick in and start being used. And that's our hot failover capability. I can also create a connection called WAN smoothing. And then I can turn on WAN smoothing. Hit save. And then I can create a rule that says, and this works better in control, by the way, but I can say source, client SSID, bonding, and I could make an SSID called smoothing, and then I could say priority WAN smoothing. And now I could have traffic like Teams and stuff like that being WAN smoothed over Starlink and cellular. And then we go to in control, which I love in control outbound policies, by the way. It's one of my favorites. So SpeedFusion Renegade, network, outbound policies. I can use SaaS capabilities inside in control to make this even better. So I can add a rule that says voice and video, WAN smoothing. And then I can say if the source is any, the destination is SaaS, and it's Zoom, Google, WebEx, and Microsoft Teams, then I could say priority SpeedFusion with tunnel 24 west, and then I can say WAN smoothing. And so if I go back here to west, and then WAN smoothing is my name. And so here's my west 2404 WAN smoothing. And then I can say fail through the next rule, terminate, hit OK, hit save. So now I've created a policy, an outbound policy that sends traffic. Look at that. Voice and video WAN smoothing. So right there, it's going to go out WAN smoothing, WAN smoothing, WAN smoothing, WAN smoothing for Zoom, Google, WebEx, and Skype. And so that's where there's like this really nice capability in control to use our SaaS applications to send content based on destination SaaS. And you can see we have a couple different applications here that are available. And so using in control, if I want to create really nice destination-based routing, I can do that. Or if you're using SpeedFusion Connect, you can use the cloud capabilities inside SpeedFusion Connect. And I know this is a lot. It gets overwhelming sometimes. And a lot of times I like to tell people, it's like, hey, we need to make sure that we're looking at the application and what we're trying to accomplish, because there is no one size fits all. I mean, look at Peplink. They have a bunch of different routers. We have the BR1 Pro 5G, which has Ethernet WAN and 5G. We have the BR2 Pro 5G, which is dual 5G with dual Ethernet. So you have 2 Starlinks and 2 5Gs. Then you have the HD4 MBX 5G that has 3 Ethernet WANs and 4 5Gs. And so depending on how you're deploying your network and what you're doing and what your infrastructure, like I get blessed with the ability to have SDX routers at my data center with 6 gigabit internet. And so I can bond back to my data center, but you might be an RV user using SpeedFusion Connect. And so these outbound policies that I'm creating here don't make sense. It's better to use the SFC Protect traffic shaping. The point though is, even in SFC Protect, you can create these split tunnels and then you can route the traffic. So you could say, hey, I want a tunnel that's Starlink only. I want a tunnel that's Starlink and cellular but WAN smooth. I want just bonding. And then I can create an SSID to use those different technologies, or I can route based on application like Zoom and Google, WebEx and Teams, and then send those over my WAN smoothing. You don't want to use WAN smoothing with just a single internet connection, because WAN smoothing uses parity bits. So if you're using Starlink with WAN smoothing and you only have Starlink, well, now you're doubling up the data. So if you're sending 2 megabits of data, you're sending 4 over one internet connection. So you're using double the bandwidth without the need. WAN smoothing is really nice when you have more than one internet connection and you're trying to make those voice and video applications as clean and smooth as possible. And if you notice that when I first logged in this router, my default, like my personal, when I travel, my default is simply just SpeedFusion, send all traffic to West 2404. I mean, that's my default. I bond my traffic back to my office and let the router do its thing. And we use dynamic weighted bonding. So my personal preference is just bond all the traffic back to my office and let it do its thing. So depending on your needs, the type of router you have, your corporate setup, whether or not you're using a router at your home or your office, or you're using SpeedFusion Connect Protect, those things all matter on how we're going to send that traffic and flow the traffic. I hope this content creates some value for you, and that you have, if you have any questions, we're here to help and answer those questions for you. And so if you have any, if there's anything we can do for you, please let us know. And otherwise, thank you so much and have a great day.